Hi, this deck of cards was compiled to facilitate working through the MCAT style passage, Feline Night Vision, and it deals with the biological foundations of behavior. Colors appear dimmer at night, therefore the photoreceptor responsible for color vision is less or more active. So is it more active or less active? I think the answer is kind of obvious. That's right, you guessed it, less active. So at night, because things get dimmer, the color receptors are less active. And color receptors have to do with the cones and not the rods. The visual field is split into two halves, each interpreted by the contralateral, that's the opposite side, or the ipsilateral, meaning the same side of the brain. So is it interpreted by the contralateral or ipsilateral side of the brain? The answer is the contralateral side. So in each eye, here highlighted in red is your left visual field. Okay, and the signals come in, they traverse through the red line in the chiasm, the optic chiasm, all the way to the right side of the visual cortex. But the left visual field is actually being interpreted. Okay. The nasal side of the eye is the side closest to the ears or nose, while the temporal side is the side closest to the ears or nose. I think the answers are pretty obvious, but I just want to orient you a little bit. It's important. So what's the answer? So nasal side closest to the nose, temporal side is closest to the ears. So here goes an example with the right visual field. So this side is the nasal side, closer to the nose. This side would be the temporal side, closer to the ears. Okay? All right. I mean, don't strain your eyes and read this. Just let me do the reading and you do the answering. Light from the left visual field enters the left eye and hits the temporal side of the left eye and the nasal side of the right eye. Since the light is coming from the left visual field, it is interpreted by the opposite contralateral side of the brain in the left or right hemisphere. So which hemisphere is it, the left or the right hemisphere? It would be the right hemisphere. So here we see the left field of vision in the left eye coming in from the temporal side and the left field of vision in the right eye. Okay, on the nasal side, it's going to traverse through the red highlights in the optic nerves and be interpreted in the right hemisphere in the visual cortex. So I'll just give you a moment to take that in. If an incident light ray that entered the eye is reflected off of the choroid, the structures that it will pass through include the T blank M, L blank M, retina, vitreous humor, lens, pupil, aqueous humor, and cornea. So after reflecting off the choroid, where will light travel next? That would be the tapetum lucidum. So here is the tapetum lucidum. First the choroid, okay? Then the tapetum lucidum, this layer. Then the retina, this layer. Then all this gooey stuff here, the vitreous humor. Okay. Then the lens. All right. Well, here, lens, the pupil. But the pupil's kind of like an opening, as well as the iris, the coloring. Okay, and then we have the cornea. But before the cornea, the aqueous humor, this region right here. So I'll give you a moment to take that in. The parvo pathway is responsible for spatial resolution, like what something looks like, while the magno pathway is responsible for T blank L resolution. So what type of resolution is the magno-visual pathway in the brain responsible for? That would be temporal resolution. And when I say temporal, I don't mean the actual temporal lobe. I mean temporal, like time. Okay, so things like movement, spatial transformations, motion, that all relates to changes in time. Okay, whereas the parvo pathway isn't responsible for this type of spatial, it's responsible for what occupies the space, like shape, size, basically pictorial details. Okay, I'll give you a moment to take that in. The parvo pathway is responsible for detecting fine details, such as the form and color of an object, while the magno pathway, I always say pathway, I think it's the Jamaican in me, detects rapidly changing components of an object, such as M blank N. So rapidly changing components of an object is also known as what? Motion. Okay, so the dorsal stream or the magno pathway handles spatial processing as it relates to motion. That's movement, your location at one time versus your location at another time. All right, and transformations within the same location or different locations. The fovea, and that's the fovea of the retina, is extremely rich in C blank S and is responsible for fine details in your visual field as well as for your color vision. So what type of structures are responsible for this? That would be the cones, and this little dip, this little indentation right here in the retina is the fovea. Most of your cones are located right there. So that little dot is responsible for all your wonderful color vision. For those people who aren't colorblind, and if you are, I don't mean to offend you. Rods are scattered throughout the eye, but mainly are found outside the blank region in the periphery of the eye. So in what region won't you find rods? And it's a region in the retina. Again, the foveal region, because it's concentrated with cones and not rods. You might have one or two specks, but for the most part, the fovea is concentrated in cones. Blank are extremely sensitive to light and are thus very important for night vision, though do not differentially respond to light of different wavelengths, and thus, I said thus, it's definitely my Jamaican roots, are not able to detect color. So what structures in the eye are not able to detect color? That would be the rods. And here I have highlighted rods. So here you have cones responsible for different wavelengths. Red, greens, blues. But the rods, they're not responsible for that aspect of your vision.